The thinking machine and the thinking mind. I want to make a deep comparison between a quantum computer and the human mind. We can reveal the same idea, like, is the brain a quantum computer? And that's the point. That's the point that I'm trying to share with you. I want to make an argument. I want to talk about. I want to share. Right now, in your head, you have nearly 86 billion neurons, and these neurons are firing. Each one is making decisions without switches, without wires, without codes. And yet, here we are. We are building machine, or I may call the machines, what we call as quantum computers. So delicate that a tiny vibration, a tiny whisper, a single stray particle can destroy the whole of the calculations. So let me ask you something profound, something important, something that might make sense. Is the human brain merely a biological machine? Or are our most advanced machines only the faint shadows of the biological brain? So guys, today I, our Father for those, invite you on a small show where physics meets mind, where quantum computation meets consciousness, and where science bows humility before the mysterious surroundings. This is not a claim. This is not a belief. This is simply a comparison that I'm trying to make. This is a comparison that's basically grounded in reality itself. So, you know what is a quantum computer? As usual, I talk about it because it becomes a very fascinating machine to us. A quantum computer is not a faster classical computer, as I said. It is a fundamentally different way of processing reality. And again, I would like to make a small comparison between a classical computer or a classical information and a quantum information. A classical computer is using as I say usually, I want to repeat it again and again so that it becomes a common voice. It works on zeros and ones. It works on and off. It works on true and false, right, wrong. All that technology that we have in terms of computers. A quantum computer uses the quantum bits. It is not 0 or 1. It is 0 and 1 at the same point of time until measured. This property is called superposition, as I'm revealing again and again, putting my whole stress to make it popular. Mathematically, a qubit is is basically it's a state. It's a state of a quantum system. Reality exists as probability here. It does not exist in the form of certainties. And you can already note some of the important things here, like quantum computers do not deal in certainty, they deal in possibilities. It's not like the computer that we have been using. We have here an important argument, the argument of entanglement. It's a very strange kind of communication between the particles. When quantum bits become entangled, the state of one instantaneously correlates with another. They don't correlate by virtue of a signal, they don't correlate by virtue of force, but they are merely correlating with each other due to the mathematical reality. And Albert Einstein called this spooky action at a distance. In quantum computing, information is basically distributed, meaning the information is non-local. The system behaves as a whole. Fragility and decoherence. Quantum computers are extremely fragile, and you need to cool down them. You need to take them to close to absolute zero, minus 273 degrees Celsius. It must be isolated from noise. And why? Because quantum states collapse when you disturb them. And this tells us something important. This reveals something important. This is something that expresses something more profound. Quantum computation is not robust by default. It requires those extreme controls, and you have to keep this thing in mind. You have to have circumstances like this. Now, what is the human brain? Now, let's talk about the brain that nature has provided us. Now, let's turn inwards. The human brain, a few hundred grams of biological matter, consumes only, on an average, 20 watts of power, works in heat, noise, chaos. It recognizes faces instantaneously and generates meaning. When we look at the things, creates music, mathematics, morality, immorality. Neurons. These neurons, they are not wires. Neurons do not function like transistors. They don't function like logic gates of a classical computer. They are electrochemicals, non-linearly working. And each neuron integrates thousands of inputs. It's an integration of thousands of inputs and fires probabilistically them out and changes its own structure over time. The potential of Almighty, the potential of reality. The brain is adaptive. It's not fixed. It adapts to the situations. There is parallelism beyond machines that we have been about to build. If we talk about the classical computer process, billions of operations per second. But sequentially, the brain process massive parallel activity with no central clock, with no central controller. It's an overall job of the billions of neurons. The brain is distributed. It's a distributed intelligence. Noise is not a bug. In computers, noise is an error. In the brain, noise is creativity. Noise is flexibility. Noise is learning music, mathematics, learning. The brain embraces this uncertainty. Now, why are the two, the brain and the quantum computer, why do they meet? How can I correlate the two? Now comes the critical comparison. The first important point is the superposition versus cognitive ambiguity in the brain. In quantum systems, what we have a qubit, and this qubit can exist in multiple states at the same point of time. At the same time, in the brain, we have thoughts, and thoughts exist as overlapping possibilities. And here you have decisions coming, the decisions emerging after deliberations. Before you decide, you are not in one state. You are in multi-states. You are in many tendencies. You are in multiple domains. You have entanglement. And you have neural bindings. The brain solves this binding problem. Colors, shapes, sound, emotions, unified into one experience. This is not fully understood. This is not fully realistically understood. Soon, there were scientists, they propose something called temporary synchronized states, distributed coherence. No doubt there is not a proof of quantum computation, but at the same point of time, there is some structural similarity. There is collapse in quantum computer. Here in the brain, you have the decision. So in quantum systems, the moment you make a measurement, there is a collapse of the probability. And in the brain, the action that you do, it collapses the all other intentions that were existing before that action. Reality becomes actual only at the moment of the choice. Now let's be honest. Let's be very honest in this argument. Is the brain a quantum computer? There's no confirmed evidence of this thing. Do neurons behave like quantum bits? Do they behave like qubits? Not in any proven computational sense. No. And does consciousness require quantum mechanics, still an open question, a question that's open. But, but, does the brain exploit uncertainty? The answer is yes. I cannot ignore this reality. Brain exploits uncertainty. Does cognition rely on probability? The answer is yes. It relies, it believes probability. Does meaning emerge, not compute? Absolutely, yes. The similarity is conceptual, not literal. You cannot make a literal similarities between a quantum computational brain and a human brain. What quantum computers does, there are quantum computers. They compute probabilities rather. Brains, they live those probabilities. They experience those probabilities in the form of thoughts. Now let me have a humble perspective. Across the cultures and traditions, one idea appears. Reality is not fixed until it's experienced. And what physics says about it? Physics says the observation that you do using a telescope, using a microscope, these observations matter. And then you have those inner experiences going on in the brain. Awareness shapes the meaning. This is not that I have been talking about any kind of religion. This is not any kind of dogma. This is shared human insight. The universe operates with this kind of balance, with these kinds of possibilities. There's a kind of restraint. The brain mirrors this. What it mirrors the flexibility. It mirrors the awareness. It does choose responsibility at times. So here is the truth. The truth is quantum computers are not trying to replace the brain. They are not trying to learn humility from the nature. And at the same point of time, the brain is not a machine pretending to be human. It's a living interface between the possibility and the reality. The possibilities are superposed, and there's a collapse of these possibilities into one reality. We build quantum computers to touch the edge of what the universe allows. But the brain, what can I say about the brain? The brain quietly, effortlessly has been standing at the edge all along. I am Arfat Firdaus. I pronounced it wrong. I'm Arfat Firdaus, and this was not a claim about the consciousness, not a challenge to any kind of belief, but an invitation to think deeply, to remain humble, and to respect the mystery that still surrounds us, by heavy numbers. If this reflection resonated with you, if it touches you, if it makes an influence on you, because the greatest computation is not done by the machine. It's not done by the machine. It's done by the mind that asks questions. If you want to realize this reality, then certainly you can feel that. You can feel that oneness. You can feel that unified action. You can feel that unified force that's running all the affairs of anything that's observable in the universe, what we call as observable universe, and beyond the observable universe. And we have no physical interpretation of that reality. But the truth is that reality is making all the affairs running in all formats, from an individual human being to the atoms, to the protons, to the electrons, to the neutrons, to the quarks. That is a beautiful probabilistic design of